Αγαπητοί συμμετέχοντες, καλώς ορίσατε στο διαδικτυακό μας σεμινάριο. Ο λόγος στην κυρία Ελίζα Βασιλείου, δεύτερη αντιπρόεδρο του ΕΤΕΚ. Ευχαριστώ.
Αγαπητοί συνάδελφοι, σας χαιρετώ και σας καλωσορίζω στην σημερινή διαδικτυακή συνάντηση με θέμα χρηματοδοτούμενα προγράμματα BIM με συμμετοχή κυπριακών φορέων, BIM και καινοτομία. Στη σημερινή ημερίδα θα παρουσιαστεί αναλυτικά το έργο ENCORE, το οποίο χρηματοδοτείται από την Ευρωπαϊκή Ένωση και το πρόγραμμα Ορίζοντας 2020. Το ENCORE αφορά στην ανάπτυξη μιας ενεργειακής και οικονομικά αποδοτικής πλατφόρμας νέφους BIM για την ανακαίνιση κτηρίων ιδιωτικής χρήσης. Η λύση του ENCORE είναι μια ολιστική λύση, η οποία καλύπτει τη συλλογή δεδομένων από αεροφωτογραφίες και χάρτες, ανάλυση και επεξεργασία των φωτογραφιών, ανίχνευση και ενίσχυση σχεδιασμού, αυτοματοποιημένο προγραμματισμό εργασιών και προσομοίωση εξοικονόμησης ενέργειας επίπεδων άνεσης και προτινόμενης λύσης. Συντονιστής της σημερινής συνάντησης θα είναι ο κύριος Νίκος Γκουβέρης, Διευθυντής Τμήματος Τεχνολογικής Ανάπτυξης στον Αναπτυξιακό Οργανισμό Τάλος. Είναι συνάδελφος μηχανικός μεταλλείων. Ο λόγος σε εσάς, αγαπητέ συνάδελφοι.
Κυρίες και κύριοι, καλημέρα σας. Ευχαριστούμε πάρα πολύ που μπήκατε στη σημερινή ημερίδα. Ένα λεπτάκι να μοιραστώ την οθόνη μου μαζί σας. Λοιπόν. Εκ μέρους του Αναπτυξιακού Οργανισμού Τάλος, θα ήθελα και εγώ να σας καλωσορίσω, όπως είπα, στην σημερινή μας εκδήλωση. Η Τάλος είναι μια εταιρεία η οποία παρέχει ευρεία γκάμα συμβουλευτικών υπηρεσιών. Ιδρύθηκε το 2020 και έχει στο ενεργητικό της συμμετοχές ίσως σε περισσότερα από 80 χρηματοδοτούμενα έργα, τόσο σε ευρωπαϊκό όσο και σε τοπικό επίπεδο. Η σημερινή μερίδα έχει σαν σκοπό την ενημέρωση του κοινού για τα επιτεύγματα 3 αξιόλογων και άλλων επιτυχημένων έργων, τα οποία χρηματοδοτούνται τόσο από την Ευρωπαϊκή Επιτροπή όσο και από την Κυπριακή Κυβέρνηση, μέσω του Ιδρύματος Έρευνας και Καινοτομίας, και για τα οποία συμμετέχουν κυπριακοί φορείς. Για λόγους συντομίας, είναι συνήθις πρακτική τα χρηματοδοτούμενα έργα αυτά να ονομάζονται και να αναφερόμαστε σε αυτά με ένα σύντομο ακρονίμιο, παρά με τον πλήρη τίτλο τους. Τα έργα που θα παρουσιαστούν σήμερα είναι τα ENCORE, URBAN PERISCOPE και BEEP. Ο οργανισμός μας, η Art συμμετέχει στα έργα ENCORE και URBAN PERISCOPE και έχει το ρόλο του υπεύθυνου επικοινωνίας και τον υπεύθυνο της διαχείρισης και της εκμετάλλευσης των αποτελεσμάτων. Η σημερινή μερίδα δίνει έμφαση στο έργο ENCORE, το οποίο αφορά την ανάπτυξη μιας πλατφόρμας BIM στο νέφος, στο cloud, η οποία παρέχει μια ολιστική λύση ανακαίνησης ενός οικιστικού κτηρίου, με ιδιαίτερη έμφαση στην ενεργειακή απόδοση και στην ενεργή εμπλοκή όλων των εμπλεκομένων φορέων, τόσο κατά τη διάρκεια της ανακαίνησης, όσο και κατά το monitoring, της παρακολούθησης δηλαδή της λύσης που έχει αναπτυχθεί μετά το πέρας των διεργασιών. Το ENCORE χρηματοδοτείται από το πρόγραμμα Ορίζοντας 2020 της Ευρωπαϊκής Επιτροπής και ανακηρύχθηκε από τον περασμένο Δεκέμβριο από το σημείο επαφής της Γερμανίας των Ευρωπαϊκών Προγραμμάτων ως ένα πλήρες success story, καθώς λύνει ένα πραγματικό πρόβλημα με μια άκρως καινοτόμο προσέγγιση. Δεν θα μακρηγορήσω όμως, άλλο το πρόγραμμα της σημερινής εκδήλωσης φαίνεται στον παρακάτω πίνακα. Υπάρχουν 9 παρουσιάσεις στο σύνολο. Το ENCORE και τα επιμέρους συστήματα που το απαρτίζουν θα παρουσιαστούν σε 8 παρουσιάσεις των περίπου 15 λεπτών η κάθε μια, ενώ στο τέλος θα παρουσιαστούν πιο επιγραμματικά και τα έργα URBAN PERISCOPE και BEEP από τους συνεργάτες μας στο Ινστιτούτο του Κύπρου. Πάμε να ξεκινήσουμε. Την πρώτη παρουσίαση θα την κάνει ο κύριος Σεμπάστιαν Σόλτσε, ανώστερος λειτουργός στο ATB Institute for Applied Systems Technology in Bremen, ενός μη κερδοσκοπικού ερευνητικού οργανισμού με έδρα τη Βρέμη. Mr. Solce, the floor is yours. If I can stop sharing.
Okay. Thank you very much, Nikos. Give me a second to share my slides. So I hope that you can see the slides now in full screen.
Yes.
Good. So my name is Sebastian Scholze. As Nikos already said, I am coordinating this project ENCORE. And we will present you today in several presentations what was the idea of ENCORE and our results. And I think it's quite nice set of presentations that we will be able to show you. Just briefly, I'm working for ATB. That's a private research institute located in Bremen. That's northern part of Germany. Maybe in the beginning, some facts about the project ENCORE. We have partners here all over Europe. It's a Horizon 2020 project. It was funded under this call Energy Efficient Buildings. It started January 2019. Duration is 42 months. We from ATB, we are the coordinators. And so you can see already, as it started in 2019, we are now in the final phase of the project. Maybe in the beginning, what was the main objective? Our idea was we wanted to provide BIM tools that are effective and affordable, and we wanted to accelerate the whole renovation life cycle, and this from collection of the data, then project execution, and also then commissioning and delivery. And of course, we wanted to take into account the energy efficiency and comfort parameters and involve also all the actors in the process of these renovation projects. So what was the initial idea? To build a BIM cloud-based solution, and we wanted to address or support actors in this process for renovating buildings by automatic data acquisition. So you will, about all these topics, you will hear in the following presentation something. So using drones to build automatically a BIM model, by this automatic segmentation and classification, automated or assisted generation of BIM models. If you have these BIM models, we have the idea to enhance these automatically with additional information. We want to address energy efficiency and comfort simulations, get end users feedback supported by augmented and mixed reality, automatic generation of task of renovation process, and of course, continuous monitoring of facilities. And all these should be able to be used and executed using a web-based cloud solution. So on the right side, you see the conceptual components that we wanted to address. And then in the last 3 years, we came up with an architecture. So we have a layered architecture. On the bottom, you see several data sources. So BIM objects, data from the drones, photogrammetry and LiDAR information, sensory information from the building, data from weather stations, but also online available data like Google Maps to get information from this. The next layer is processing this raw data information. So to be able from this photogrammetry and LiDAR create point clouds and photos and use these to create a BIM model, and also use the sensory information to enhance these BIM models. Then in this ENCORE engine layer, we are working on these data sets to get more meaningful data. And then on top, we have all these applications that I already mentioned on the slide before. Okay, that's some sort of a software architecture, but these renovating buildings is a quite complex process, so we also came up with an ENCORE workflow on how a renovation project should work. And you can see this here. So we are starting with creating a renovation project. Then you have to generate or add a building model, assess energy and comfort before renovation, then define renovation alternatives, and so on. Decide what to be done, plan the renovation work, enhance the building model, monitor the renovation work progress, and after the renovation is done, support the operation of a renovated building. So then we mapped all these things to our components, what we are developing in ENCORE. And you can see, for example, here in this ENCORE portal, that's the entry point for the ENCORE solution. We have some visualization tools so that we can view and visualize the BIM models, have some energy assessment, on-site design analysis and verification. So these are the web-based applications. In the background, you have the backend services. And then, of course, we are able to get the data from various data sources. So, and then the next slides, I will show you this ENCORE portal. That's the entry point for the integrated ENCORE solution. So it's a web-based solution. You can access it via any web browser, and then you can sign in. And the first thing what you see is the overview of your current renovation projects. And this lower project and EDIA demonstration building, that's our pilot case in ENCORE. If you select this, you will see a page like this, and then you have several options here. So what is highlighted in red now is this project basic information. So you have a project name, customer name, addresses, and a small description what will be done with this renovation project. You can involve several people. In this example here is only the project coordinator, but you can involve several people and invite them to work on this project so that a group of actors can work together collaboratively. And on the left side, you have access to all of our ENCORE tools. So for example, we are now in this project overview, the building monitoring, it's a building monitoring solution so that you can get live data from a building sensors. This energy and comfort simulation can be executed from here. You can do a design analysis, the work planning, the monitoring, and this building operation support. Then, in case you have a building model already added to this project, so in this case, we have this. So the first step would be to add this building. Either you already have such a thing, or you create it using the drones and this image processing engine. You can click on this show in BIM viewer. Then you will see something like this. That's this demonstration building, what we're using in ENCORE. And you can see the current state of the building. In the next step, you would go and select what to be renovated. This you can do, for example, by using this energy and comfort simulation and by the design analysis. And the result will be a second BIM model. And in this BIM model, there's the possibility that you can show what to be added. So in this case, we want to add some shades for the windows, and on the backside of the building, we want to replace a window and add some insulation at the wall. And on top, you have here this checkboxes, and you can select and then see highlighted in green. So in this example, I highlighted these two shades. So you can see these are things we want to add in the renovation project. If you have done this, in the background, there's an engine called Knowledge Extraction and Enhancement Service, and this is running continuously and trying to enhance these already existing IFC files, so the BIM model, and we are adding their semantically information. So, for example, we are trying to attach or connect installed sensors in the building with the objects to be renovated, and the result looks quite similar to the one before. But what you can see here in these tags, that on top we have added here a sensor, so you know that with these objects some sensors are connected, and that's I think quite nice, because this is automatically done. So there's no need to manually update this information. Okay, that's the main part for this building. Last slide from my side is this one, our roadmap. I already said that we started beginning of 2019, so around summer 2019 we had our concept and architecture ready. Then autumn 2020 we had first prototypes and did some first let's say developer testing. Autumn last year we had our full prototypes ready, and now we are in the phase of testing our integrated solution and doing the final polishing, so that in summer 2020 we will release the final prototype. And of course we are now doing this demonstration, and what we are doing now is some part of this. And what we are planning is to make a demo instance of this publicly available, and maybe you will receive in a few days or weeks some information and from Nikos and with a link, and we would be happy if you try this out and give us then some feedback. That's from my side. And then I think on these other components, you will get a much more detailed information from the following presentations, and not just these high level on the first two slides from my side. And yeah, that's from my side. Thank you.
Thank you very much, Sebastian. As Sebastian said, in approximately 2 weeks to 1 month from now, depending on how things go, you will receive a live link in order for you to experience the platform from yourselves. It needs a little bit more tinkering in order to make sure that everything works. In any case, thank you very much, Sebastian. You can go ahead and stop your sharing screen. Next up, Mr. Sergio Munoz. Yep.
No, I just had to look at where to find the stop button.
Great. Hello, Sergio. Sergio is CEO from Laurentia Technologies, a technology startup based in Valencia, in Spain, which is established in approximately 2014, and they offer consulting services in nanotechnology and also BIM technology. So, Sergio, the floor is yours.
Thank you, Nikos. I think that probably you see my screen, is right?
Yes.
Okay. So, hi everybody. I'm Sergio Munoz from Laurentia Technologies. We are a small Spanish SME, and we make BIM consultancy, and we have participated in the ENCORE project, developing a platform to make the energy assessment of existing and retrofitted buildings. So, as Sebastian has explained it before, the renovation process has several steps, and probably the first step is to create the building information model. So the building information model has geometry and alphanumeric information, and we have several options to create that geometry. So we are going to explain you all these three ways to create the geometry, and I'm only to focus in one of these three ways. I'm going to focus in how to create the geometry based on online data sources. So we have developed a platform which makes online data acquisition, which takes existing buildings geometric information from existing online sources. So what we need to do is to take this information and to create, using this information, the building information model, creating the spaces, creating the floors, creating all the elements of this building information model. So we have three different online sources. One is based on the national cadastres that are in each country, but in fact, for this project, we have worked only with the Spanish cadastre because, well, each cadastre in each country is different and are not the same rules about how to manage the information. We have developed a very simple tool to draw manually the envelope of the building. And finally, another source is about a service called 3D Buildings, which have information of many buildings in Europe, and is very useful for us. What's what we do? So we take information about the envelope, about the coordinates. Sorry, I think that there is any micro open, please. Can you close? Yeah, I think that.
Yeah, thank you.
Okay.
Richard, your microphone is open. Can you please shut it down? Yeah, great. Sorry, Sergio.
Okay. So we need to take all the points of each facade, of each wall of the envelope. We need the information about the number of floors. We need the information about the floor height. We need to know which is the areas of the windows in each facades in order to create the geometry of our building information model. So I'm going to explain you very briefly which information we have in each one of these sources. So in case of the Spanish cadastre, we have many save files, one per each municipality. We can take information about the polygon of each floor and the height of the building, and another interesting information like the year of construction, if there are some levels underground, for example, and information about of the surrounding buildings, for example. So here I'm showing to you our database where we have storage the shape files of many towns in Spain. So the second online source is 3D Buildings. It's a global database of buildings with different level of detail depending on the country and cities. There are some cities and some countries with a good level of detail of the buildings, but in other cities or other parts of some cities, we don't have, for example, the information of the number of floors of the building. This is an example of which is the information that has 3D buildings from Nicosia, for example. And finally, the last option is just to let the user to draw manually using Google Maps as reference. He can draw the envelope of the building, and he can indicate which is the floor height or the number of floors, and indicate if a wall is a facade or a party wall, or add a courtyard, for example. So that's what we can do. We take this information in order to create the 3D model, extruding the floor polygon, taking into account the floor height. This is the result at the end of the process of reconstruct the building information model using these online sources. And I'm going to show you very quickly 3 different demos using the different online sources. This one first. Okay. So we are going to create the geometry of a building in.
Sebastian, sorry, Sergio, we are still seeing the presentation.
Okay, wait a minute.
Yeah, thank you.
I think I have to change
The screen.
Yeah.
Yeah, thank you.
Yeah. Mm-hmm. Now, can you see my?
Yes.
Okay. So this building is a building in Nicosia. So it's a building that I don't know this street, but I found it. Probably you know better than me, I'm sure.
It is a quite busy road.
Okay, so I use, in this case, I select 3D buildings like the online source. As you can see, the geometry provided by 3D buildings is a little bit different than in the map. And sorry, okay, sorry. But I have the information about the number of floors, for example, of that building. So I assume that this is correct, this geometry, but if not, I can reset and I can draw manually. Okay. This is another part of the process that I will explain you later, because we need to give additional information to our building information model. But the important is that finally we have this 3D building model for that building. So now I'm going to show you another example. In this case, we are going to use the Spanish cadastre. So I'm introducing an address in Valencia, in Spain, in my city. So, okay, I add some information about the climatic file. And here I select as online source the Spanish cadastre. So, and I get this information about the envelope. But for example, I don't get any information about the courtyard. So I'm going to add a courtyard to this building. I have to specify in which floor arrange the courtyard. So this is the courtyard. So, okay, this is the same process to specify the technical requirement for the building. And finally, I have my 3D building information model for that building. And finally, it's another example. In this case, I don't get information from 3D buildings, and I'm going to, it's another building in Nicosia. The address is Nikis 21. And I'm going to draw manually because I don't get information from the 3D buildings API. But it's quite simple because in this case, I can use Google Maps as reference in order to draw the envelope of the building. I can specify the number of floors, for example, 6. I don't know if it has 6. I say which are the constructive solutions and the technical equipment of the building. And finally, I have the building information model. So let me. So that's really all. What I wanted to explain you is that this is possible because for making the energy assessment of the building is enough to have the building envelope. We don't need information about all the internal walls of the building, for example. It's enough with the envelope of the building, and these online sources give us enough information to make to create this type of building information models. Thanks for your attention, and later on I will explain you other parts of these tools.
Thank you very much, Sergio. Next up in the presentation list is the second method that we are using in order to extract information from buildings. Dr. Stjepan Bogdan is here to join us from the University of Zagreb. Dr. Bogdan is a professor of the electrical engineering school in the university, where he teaches classes like robotics and automation. Stjepan, the floor is yours.
Thank you, Nikos, very much. Hi, everybody. I hope you can see my screen. It should be first slide of my presentation there.
Yes.
Okay, great. So as Nikos already said, it's great to have you all here and to present you our work on ENCORE project. I will continue where actually Sergio stopped. And Nikos mentioned this is the second way how we can acquire data for the buildings that we would like to renovate. It's actually data acquisition service that is based on unmanned aerial vehicles. Popularly, they are known as drones. So as those are the PhD students and postdocs that work on the project, and all credits, everything that you will actually see, all credits go to them, because those are hardworking young men and women that provide all those information that I will share with you today. So this is what we would like to do if we have an old building. What we do with the UAVs, we create a point cloud. So this is like a part of this artistic view of our process. This is the point cloud on the left side of the slide. And then once we have this point clouds that are acquired by UAVs, as I will show you shortly, what we would like to do, our partners would like to do within consortium, out of this point cloud, they would like to create the BIM model, as Sergio mentioned a few minutes ago. Data acquisition service is part of the ENCORE architecture that was presented by Sebastian at the beginning of the talk. And we are one of the data sources, photogrammetry and LIDAR, that goes actually to image processing and extraction that will be explained later on. As I said, data capturing is done. We receive and we obtain point clouds and photos. And then based on this, there is a service that is called image processing and extraction that actually process those data and then go further through the pipeline of the ENCORE architecture. So what we do with our UAVs, as I will show you later on, we also use Google Maps, we use cadastre data. We find a building that we would like to scan with the UAVs. We are using LIDAR systems. Then we just mark points on the map. And then based on those points on the map, our vehicles fly around the building, collect data, and then those data are used for make 3D models. So this is actually the pipeline of ENCORE. Now, in more details, as Sergio already described to you, within Google Maps and cadastre, we find the building that we would like to scan, that we would like to build a point cloud. And many times in cadastre, for example, here in Croatia, cadastre doesn't have so much details as cadastre in Spain. For example, we don't know about the floors and many information are missing. what we actually have, we have just layout of the building. And this is the first step. Our application just gets data from GMaps, the coordinates of the building, that those data are fused with the data from Cadastre. And then operator just pinpoint waypoints that should be flown by vehicles in order to follow particular trajectory. Once those waypoints are set, then our system plans trajectory for UAVs, for drones, and we would like to do the scanning of the building with 2 or 3 UAVs. So not just with a single one, but in order to speed up the process, we use 2 or 3 UAVs, and our system plans those trajectories. Then once trajectories are completed, vehicles autonomously take off, as you will see later on video clips that I will share with you. And all trajectories and all scanning is done autonomously without piloting the vehicles. Of course, there is always operator there as a person that should take care if something goes wrong. If there is some malfunctioning of the system, then he or she takes over the UAV. But if everything goes as it was planned, then at the end, system would provide data sets with the point clouds that are later on in ENCORE pipeline are used for building a 3D model. Here are the components of the system. As I already said, there is a ground station which runs human-machine interface, which is used by the operator to put all parameters of the system. We have communication part. We can communicate with UAVs by Wi-Fi, and also we are able to send images and point clouds over 4G or 5G. And we have 3 UAVs. This is the maximum number of UAVs. Of course, if there are some small buildings, all missions could be done also with a single UAV. And on the UAV, we have a small onboard computer that actually calculates trajectory, plans wall following controller, attitude, and controls vehicle. And then hardware, this is the vehicle that we are using. Here are the details. Is anybody if interested, I can share with you later on or send you by email. It's a dedicated vehicle built for this purpose, equipped with all necessary sensors in order to provide autonomous fly of the vehicle. Payload could be up to 2 kilos. Then, as far as experiments and missions, when missions are concerned, here you can see in more details how this ground station looks like. So it's a very powerful computer with a touch screen for operator for easy of using. Then we have a router for this Wi-Fi, and also we have modules for 5G. What you can see at the bottom of the screen is actually a platform that is used for controlling the UAV in manual mode of operation, and those are 2 UAVs that we used in Spain for scanning and for demonstrating how this software works. Now I will share with you with a clip. I hope it will work. And this is the process that I just explained with the human-machine interface. So as you can see, this is the building in Spain, in Cáceres. Now operator set 4 orange points around the building, and those points go to trajectory planner. Then trajectories are planned. We have green, red, and blue UAV, and all data about position and orientation of UAVs are there. Once trajectories are calculated, as you can see, we have a blue and red one. So 2 vehicles currently are scanning the building, and operator could change the point of view, check if those trajectories are executed as planned. And also on another screen, operator could see animation of the UAV that flies around the building. Here you can see how this blue vehicle is moving around the building following trajectory, and this red one is preparing for execution. And now both vehicles scan the building on opposite side in order to provide not to collide to each other. So this is the operator's panel, and this is how operator can check the status of the system. Also all numerical data, position of the vehicle, speed of the vehicle, GPS coordinates, everything is there on the screen, status of the battery, etc. Then, as a final result, when this scanning is completed, also here you can see in live how this looks like from the ground station point of view. Blue and red vehicles. So blue one just went behind the building, and red one is over here. Now I will share with you final product. So this is the point cloud that we received after the scanning is completed. As you can see, it's of the high quality. We are using 188 channels leader on both vehicle, and you can see that we even have points of those transmission lines which are very, very thin. And this is the point cloud that goes to our colleagues from Switzerland and from Italy that later process those data and create BIM model. What we can do also, this is the scanning of the building with open windows. So we open windows and then scan the building, and as you can see, we can even see the indoor of the building. You can see the walls, you can see the corridors, so we can figure out what is the floor plan of the building from outside if windows are open. Here is just a few examples of the data for you to see what is the precision. As you can see, we are following very precisely trajectory, and here we flew 2 trajectories with each UAV. First trajectory, for example, for a red UAV was at the 6 meters. Then the second one was at the 9 meters. Then we have 2 blue trajectories. One was at the 12 meters, and the highest one was at the 15 meters. And this is data that afterwards, after mission is completed, operator could receive, and then he or she could check if precision of the following was okay. If it was not, for example, if it was poor weather, windy conditions, then he or she could repeat the procedure and make another scan. Those are the publications that have been published by our group here in Zagreb, and this completes my presentation. Thank you very much for your attention. As I said, if you have any question, you can reach us by email or just contact Nikos or Sebastian, and we are really willing to share with you more details than this just 10 minutes of the presentation. Thank you very much. Nikos, floor is yours.
Thank you very much, Sebastian. Stjepan, sorry. I'm terribly sorry. As Stjepan said, you can find a link, a button in the bottom of your screen. We have dedicated a special Q&A box in order for you to ask any kind of questions to the panelists. In order to ask any kind of questions, we will try our best to answer them for you. Next up in our agenda is our colleague from the University of ETH from Zurich, a senior researcher, Mr. Rui Gong. Rui, the floor is yours.
Hello, I think because I used the link of the Ajat, so it is showing at the Ajat. But
No,
yeah.
no problem.
Yeah, so now I can share the screen. Yeah. Can you see the screen?
Yes.
Okay, cool. So we are the image processing and reconstruction service team, belong to the Encore project and from the ETH Zurich, and we also cooperate with the senior from the Italy. So, but today we would like to present the ETH parts. And our team members include Rigon, Ajat, and Denda and Luke. And for our APIs pipeline, the main idea is to receive the 2D RGB image and the 3D point clouds from the University of Zagreb from our data acquisition service, and finally get the IFC model from the received RGB images and 3D point clouds. So it's a novel pipeline, and it's very close to our industrial applications. And we have already conducted the early prototype and the full prototype in the first exploration process. In the early prototype, our data acquisition service team from the University of Zagreb collect the image and the corresponding point cloud from the building in the University of Zagreb, and we built the ED IFC model from the image and the point cloud, and it's single building by single building. And then in the full prototype, as shown by the data acquisition service team, they collect the image and the point cloud from the spin, and it's a it's a unified two building. And finally, we can still get the IFC model from the received points and RGB images. And this is the whole pipeline of the APRs part. It includes the data pre-process and 2D building element segmentation, 3D building element segmentation, and the final IFC model generation. And in more, obvious words, we could describe each of the components in some sentence. For example, in the 2D building element segmentation, we would like to find the windows and the doors in the 2D images. And in the 3D element segmentation, we would like to find the window, door, and wall in the 3D. And finally, we would like to generate the IFC model automatically. And in different components, actually, we develop different kind of techniques. For example, in the data pre-process, we focusing on some different kind of stuff like the image and point cloud pre-process and frame selection and different videogrammetry, indoor scene reconstruction, and so on. And in the 2D building element segmentation, we have the image semantic, we developed the techniques related to the image semantic segmentation and DOM adaptation. And in the 3D building element segmentation, we have the image and geometry alignment and plane segmentation. And in the final IFC generation, we developed the automatic IFC model generation toolbox. So next, I will detail in each component. I will go into each component in more details. So in the 2D building element segmentation part, we would like to find where are the windows and the doors. We use the technique of the semantic segmentation. And the semantic segmentation would like to segment the different elements from the 2D RGB images. And for example, we would like to extract the pixel, which are the doors and the windows in the images. However, the problem lies in that we can collect the images in the real environment very easily, but labeling this kind of images with the semantic label is very hard. So it's time and cost. But we could find some of the public facade data set, which means that this kind of facade data set has already had the images and the labels which are available, and we don't need to label it by ourselves. But the problem lies in that the labeled public facade data set looks very different from our received images. So in this situation, we developed the semantic segmentation task, which trained the semantic segmentation model on the 2D RGB images and which of the public facade data set, but test the model on our received images from the data creation service. But due to the difference between the training image and the test image, we use the domain adaptation technique, which means that we add the domain adaptation module in the Hill pipeline to align the training image and the unlabeled the real image that we received. So through the adaptation in this process, we can further improve the semantic segmentation results. And we can see that without the adaptation, directly training the model on the public facility set and applying it on our received images, we will find the very bad semantic segmentation performance. But with this adaptation model, we can find that the windows and the doors can be correctly segmented. And in the next module is the 3D building element semantic segmentation. The aim is to find the windows and the doors and the walls in the 3D space. So the technique that we use here is the 2D and 3D mapping and the 3D plane segmentation. In the 2D to 3D mapping, we can project the 2D images which have been segmented in the last module with the semantic segmentation back project to the 3D space to find the windows and the doors in the 3D, also in the 3D point cloud. And in our final full prototype, we already add the wall class in this part, so we can also cluster the walls in the 3D space. And for the walls, we have additional technique like the 3D plane segmentation, which means that it aims at segmenting the plane part in the 3D point cloud. So we can also exploit this kind of technique to get the roof and the wall in the 3D. And in the final part, the IFC generation part, the include in our segmented elements of the 3D point clouds, for example, the windows and the doors and the walls in the 3D space. And we input this kind of stuff into the IFC generation toolbox. And finally, we can get to the final IFC model automatically. It's the first automatic point to IFC toolbox. It's developed by our team. So if you are interested in this kind of toolbox and the technical details, you can also send us the email or send the email to Nikos. And finally, we get the Hue IPRS pipeline, which can receive the 2D and 2D images and 3D point clouds from the University of Zagreb team and get the final IFC model. And this is from the different buildings. And in the full prototype, we verify our pipeline on the collected data set from the from our testing building in the Spain. Thanks a lot for your attention. Any questions?
Thank you, Rui.
Thanks.
Thank you. Our next presentation will be regarding the building energy modeling and the energy assessment for the project. It will be also the last presentation that is going to lead us in our first coffee break. Sergio, the floor is yours again.
Thanks, Nikos. Okay, this is me again. So we have seen how to obtain or to create the 3D model of the existing building, but for making the energy assessment, it's not enough. We need to add some information related to the materials, related to the technical facilities in order to create the building energy model. So it's good to know what is a wall, what is a window, but we need to identify which type of window, which thermal properties has its window or its wall. So we need to enrich this building 3D model for this purpose. So in our projects, we have selected Energy Plus as calculus engines. Energy Plus needs the information about the building and additional information like the internal loads data or the operational data about the schedules of the technical equipment, for example, is in a text file with this extension IDF. So we need to create all the contents for this file. So which type of information we need? So we have tried to be efficient in that way, and based on the standard, European standard 17412 level of information needed, we have defined it for each type of element, which level of accuracy, with which detail, if we need the location, if we need alphanumeric information. So it's different, the level of accuracy for geometric information that the level of accuracy for the alphanumeric information. So until the moment, we have information about the constructive solution, about the walls, the windows, and the floors, but only geometric information. So we have to enrich this information with the type of elements and some thermal properties. And additionally, we need to add to our model information related to the heating, to the cooling, to the lighting systems. We don't need the geometry of these elements, but we need to know which type of facilities, and we need to know the performance or the efficiency power. So first, we have to convert the geometry from these IFC models to IDF, because IDF is the format that uses the Energy Plus calculus engine. So we have developed it, in this case have been the people from University of La Laguna that later on will make a presentation, who has developed this service, who takes the information from an IFC file in order to convert it to IDF file. So he takes the information from the envelope of the building, from the external walls, and from each slab from each floor, and he converts it into the IDF structure. So as I told you before, we need to add additionally which type of materials, which type of walls, which type of windows, which type of heating or cooling technical facilities. So we have developed a database of BIM objects, which we can use in order to get which of these elements of the database are for appropriate for our building. So, for example, regarding the constructive elements, we have a big database with walls, with windows, with roofs and slabs. So here we can see one of the facade of our database with all the layers, with the thermal and physical properties for each layer. Because we have a good database of materials, of different materials for walls, but for glazes too. And we have another database for technical facilities. It includes heating equipments, cooling, lighting, domestic hot water, ventilation, and building automate systems. So what we have to do, once we have converted the geometry to IDF format, is to select from our database which are the type of facade, the type of roofs, the type of windows, and the same for the technical equipments, in order to get finally the building energy modeling, which has not only the geometry information, so it has information about the constructive elements for each floor and the technical facilities. So we can create the IDF file containing all this information to make the energy assessment that later on we will explain you in another presentation. So I will try to show you very quickly 2 demos. I think I have to compare this screen. So, okay, I created previously this geometry, but now here in the left side, I can select the different floors, and in the right side, I can select the different type of walls for each type of facade, for example. So, and later on, I can, okay, just I want to show you that I created the IDF file containing all this information. Okay, this is the file. So now is the second example. And in this case, the geometry provides from the an IFC file. In Cáceres, in Spain, is this example. So I locate it in the map. And for the geometry, I select to upload an IFC file. Okay, this is the 2D plan for this building. So in this case, I know that some external walls are not facades, are party walls. So I'm going to manually to select these ones. I'm going to change from facade to party walls. Okay. It's the last, that's okay. And this is how I select, for example, the type of facade, the type of windows, and the same for the technical equipment. Okay, this is the final result for the building energy model, not only geometry, so it includes these elements. And just it was comparing with the, sorry, with the, it's here, okay, with the IFC file, open it in a BIM viewer. So later on, we will be able to make the energy assessment of the existing building. And that's all from my side. So open to answer your questions if needed.
Again, thank you very much, Sergio. Very interesting. At this point, I would like to break out for about 10 to 15 minutes. I would say 15 minutes in order to take a breath, process everything that was presented. Again, I would like to remind you that there is a Q&A button down on the window from the Zoom software, where you can everybody can ask questions if something is not clear, and we will try our best to answer them after our presentations are finished. Thank you very much. See you in 15 minutes. Hello again. I hope you had a chance to clear your head a little bit. I hope everybody is ready to resume. Next up is our colleagues from University of La Laguna and Laurentia Technologies again with energy saving and comfort simulation. From our side, Mr. Jose Miguel Marquez is going to present. Jose, the floor is yours.
Thank you, Nikos.
Thank you.
Let me share my screen.
Yes.
Here. Can you see my screen?
Yes.
Okay.
Great.
Hello, everyone. This presentation is about energy savings and comfort simulations that correspond, like Nico said, to Laurentia and University of La Laguna. Working on comfort and simulation analysis has allowed us to establish different renovation strategies for the buildings, and our intention is to provide ENCORE with a list of slides with different retrofitting recommendations, focusing on not only on energy savings, in heating energy savings, cooling, lighting, and ventilation energy savings, but also on cost, payback periods, taking into account the price of energy, the work's duration, and the level of intrusion, including works outside and inside the dwellings, and if it's necessary to leave the dwellings, in order to compare the existing building with the final proposed building. For this purpose, we have divided Europe into 3 zones according to different climatic conditions. Southern Europe as warm, Central Europe cold, and Northern Europe very, very cold. And we have worked in 3 cities that represent these zones, these climatic zones, that are Madrid, Berlin, and Helsinki. On the other hand, 6 building typologies representative of the European housing stock have been selected: a rectangle-shaped building between party walls, a tower, an L-shaped building, U-shaped building, a block within a courtyard, and the building of EDEA project as a single-family house. At the moment, we only have results from the rectangle-shaped building, which are the one I'm going to show you. In a first step, we have worked on strategies for the building envelope, and in later steps, we will work on the facilities and other issues like the cost and payback period, etc. The variables that we have used in this first step are different insulation thicknesses, with no insulation, 4, 8, 12, and 16 centimeters of external insulation, 2 types of frames, aluminum and PVC, 2 types of glass, 6 millimeters single glazing and double glazing for 6 millimeters, and the use of window shades in the case of Southern Europe to improve cooling, because Central and Northern Europe has no cooling problems, of course. In relation to the addition of external insulation in the building in Southern Europe, improvements, here in Southern Europe, improvement between 40 and 64% are obtained, and between 35 and 50% in the case of Central and Northern Europe. The effects of window replacement depend on the insulation level in the building. In Southern Europe, replacing single glazing with double glazing leads to a heating improvement between 10 and 28%, more or less. And in Central and Northern Europe, between 8, here you can see, and 22%. The cooling improvements in these areas are not representative because, as mentioned before, there is no real demand of cooling in these places. The combination of the two previous strategies offer improvements of 70% at maximum level insulation and almost 50% at minimum insulation level in Southern Europe. And these values ranges from 40 and 60% in Central and Northern Europe. Incorporating window shades in Southern Europe offers maximum cooling improvement of 16%. That's all from my side, and now I give the floor to my colleague Sergio, that is going to explain the next video.
Thanks, Jose Miguel. I'm going to I can share my screen of the video. Okay. Do you see the video now?
Yes.
Okay. So this is an example of, I'm going to pause. This is an example about how to make the energy assessment of the building that I created before in the Spiro Kyprianou Avenue 24 in Nicosia, and to create some retrofitting studies in order to see which is the impact in the energy consumption of the building. So, okay, this is the energy consumption of the existing building. We can see that the most part of the total consumption provides from the domestic hot water. So probably I should focus in that point, but a 25% is related to the heating systems. So now I'm going to create some studies. The first study is only adding or improving the insulation of the facades. So I'm going to add a new insulation in the facade, and I'm going to create another study where I'm going to replace the type of some technical facilities. So I'm going to replace the hot water type. It's an electric water heater, but I'm going to introduce another electric water heater a little bit efficient, and I'm going to replace the lighting system by LEDs. So now I'm going to make the simulation. So it takes a few seconds, and it depends on the complexity of the geometry of the building. That's not too complex, so it takes a few seconds. So in that case, so this is the case that study one, I've only improved the insulation of the facades. So I have 11% of savings in heating consumption. And in the study two, I should have some improvements in the lighting and in the hot water consumption. So in the case of lighting, I have 11% of savings, but in the case of hot water, I have a very little bit savings. So I'm going to make another attempt, just editing this study two, and I'm going to replace the electric water heater, but by a boiler, a domestic hot water condensing boiler, in order to see that if using this equipment more efficient, which is the impact. So I make another simulation. Okay, in this case, it's a 4% of saving in the hot water. So we aim to give additional information relating to the payback or the work's duration. So we have some information in our database, but not, we have to fill our database with some missing information about all the possibilities to give a complete report about which is the impact of its retrofitting study. And that's all from my side in order to show you how we can create quickly different studies with different types of strategies in the passive part of the building or in the active part of the building in order to compare which is the impact using the simulation.
Thank you, Sergio. Following up, we are going to the on-site analysis and verification and the automated work planning, which is going to be presented by our colleagues in the Polytechnic University of Ancona in Italy. Dr. Alessandro Carbonari, the floor is yours.
Thank you, Nikos. Yeah, I'm trying to share this presentation. Are you able to see it?
Yes, yes, we can.
Okay.
We see the presenter's view.
Okay, not the other one. I will try to switch. Okay, let's try to with this one. Is it the correct view?
Yes.
Now? Okay.
Yes.
Thank you.
Thank you.
Thank you for warning me. Okay, yeah, my name is Alessandro. Thanks for the introduction. As you can see in the title, we have these two different services. They are called ODAPS, the first one, and AVOPS, the second one. We have been in charge of developing these two services. We made the choice of presenting the first one today and not the second one for two different reasons. The first is that they are very different. And so we would like to use our time to present the one of them. And we have chosen the first one because it has been already tested in the real-life pilot building that ENCORE has used in Cáceres, Spain. The second will be service AVOPS will be tested in a few days, the last 2 weeks of March. So in the next workshop, the next meeting that will be, of course, shared online, we will present the other service. What's the difference? ODAPS is a service supporting the design phase, while AVOPS is another service supporting the construction phase. So they are different, and also they both need some time to be presented. Okay, let's start. So let's go into the details of ODAPS. The basic concept is what you can see on the slide. So in every design process, people must cooperate from different places at different times, and it's always several skills must be put together in order to define the renovation design of a building, and the designer or the design team very often requires that the experts or the people in charge of construction works advise them about some technical choices. And in ODAPS, this is done with the help of augmented reality and mixed reality. That is that possibility of overlapping holograms to reality in order to check for consistency, for clashes, or other reasons. So what we see is that the design team will work on design alternatives. In case there is a specific problem about the wider area of constructability, the assessment can be made on site by the most expert people available. That is very often a technician. And there is no need that all these people meet in the same place at the same time, because thanks to ODAPS, this process can also be done in an asynchronous way. So some of the advantages are listed in this slide. First of all, we can put together several skills in order to reach the best decision. The second is that collaboration is not required to be asynchronous. the architect can make some request for advice, and then as soon as the expert or experts, more than one, are available, they can go on site, do their assessment, and save their comments in the ODAP service that we are showing in a minute. And this realizes the cooperation between man and machine, where machine has this task of extending the capabilities of man, and so bringing the process towards a better results. The final impact is a better efficiency, but also reliability, because the number of errors will be reduced thanks to others. So what we have developed is a couple of applications. The first one is the application running in the ODAPs, in the headset, so the glass that you will see in a minute. And this glass does several things. First of all, it downloads the model to be displayed, and it manages the model in terms of alignment, in terms of visualization. And the expert wearing this glass at the end can leave some comments on the web service. Just a couple of words about the integration in ENCORE. Both Sebastian and Sergio has said something about this. I will remind you that in ENCORE, as the main workflow, includes the development of several design renovation options, and these options are called studies. Of course, all the options are assessed from the energy point of view using the system that has been shown in the previous two slots. But as I said, in case of some constructability issues, a subset of these studies could be further assessed by means of ODAPs. And then it's where this process takes place. And as I said, this is made of an app running in the glass and another web guide that is used by the architects to upload the models and then download the comments that are made by the expert. We want to make your ideas even more clear thanks to a live demonstrator that my colleague Massimo will carry on right now in a minute. And just to be clear, the demonstrator will be done in a couple of rooms in our department. As this is about renovation, what you can see in the slide is on the left side of the slide, the current layout of these two rooms that we have in our department. And then in the other service, we simulate this process of renovation. So the future layout we envisage for these two rooms is that there will be an additional rooms at the entrance, and then the rooms will be reduced in size, and also the furniture a little bit relocated. Similarly, as you can see in the review, there we would like also to put a new ventilation system. So this is what will be assessed right now. So now I would like to switch the screen sharing and also the floor to my colleague. I expect that Massimo will take over the presentation right now.
Yes, thank you, Alessandro. Just give me a second. Okay, can you see my screen?
Yes, Massimo.
Okay. I'm Massimo, as Sandro said, and in this moment, I'm embodying the role of an expert that is in charge of making an assessment about some renovation options that has been designed to the BREA system in the ENCORE portal. What you can see now is my view, that is the first-person view of the app that we have developed in Microsoft Unity platform. And I'm wearing an HoloLens that is a mixed reality headset designed for allowing the user to interact at the same time with the reality and with the holograms that are virtual objects placed in the space. This is the main menu that allows me to connect to our server that is synchronized with the ENCORE portal and show me the projects that are available in the portal. Now we can see Cáceres, UniPM, and Demo. I select UniPM, that is a project related to our department. In this case, we have just one renovation option, this renovation demo. And when I select this option, it downloads, sometimes it downloads the model from the server to the headset, and then it allows me to see the model overlapped with the reality in order to check the constructability, mainly the constructability of the renovation design. Now the menu is changed. You can see different buttons in front of me. But the first thing I have to do is to align the model with the reality. Otherwise, the model will be completely misplaced with respect to the real world. And in order to do this, I have just to visually detect two known objects that are two tags that we have developed and put in known positions in the space. If I move in front of the first one and I look at it, you can see a square around the tag. I can select square by an gesture, and it becomes red. This means that the tag has been recognized by the ODAS application and by the server, and it is matched with the corresponding tag in the model. Now I have to detect the second tag that is placed here. I fix it. Now the model has been displayed and is completely overlapped with the real world. As you can see, I can move around and see also the new furniture that is inserted in the renovation design. But what is more important is the new window, for instance. It is smaller than the actual one. And the new partition that reduces this space and creates another space on the other side that connects this room with the next one. You can see a new door there. I can move. As you can see, the model is completely fixed in the space, in the real space. And I can look at the virtual objects as I look at the real objects. I can check the position of the door, the new corridor, and the door in front of me. And in order to make a better assessment of the renovation option, it's useful to hide some components in order to see what is behind. For instance, I can hide the entire envelope. And now I can see also the furniture, for instance, of the other room that is not visible from this point normally. The new furniture inside this space. And it remains a countertop above me that hides the new ventilation system that I want to assess. So I show again the envelope and I hide the countertop. Now, as you can see, the new ventilation system is visible above me and above the countertop, and I can move around and check if everything is okay. For instance, here, as you can see, there is a menu. there is an outlet for the new ventilation system that is partly overlapped with the lighting appliance. Then maybe I want to leave a comment to the designer that tells to the designer to change his design and to fix this problem. I can select the object and I can record a voice comment. This outlet is partly overlapped with the lighting appliance. This outlet is that comment will be linked to the BIM objects, the corresponding FC object in the model, and that comment can be listened to by the designer in order to address the issue and to solve this kind of problems. We could also leave other comments, for instance, to the attach it to the new partition, the new door. Also, it's possible to listen comments left in the space by other actors, other experts that maybe are using the same platform. For this application, that's it. I can now get out from the application and share another window. Give me a few seconds. Okay. Okay, here you can see the web app that is the backend application of the ODAS service that is synchronized with the ENCORE portal that loads the project, the studies that are uploaded by Brea, as Sergio shown before. And the studies can be also manually loaded if needed, but they usually are automatically synchronized with the ENCORE portal. When we have made the assessment, we can manage everything inside this server. In particular, we can listen to the comments that I've just left attached to the outlet. As you can see here, there are several comments. What I show you is something related to another demonstrator that is already loaded in ENCORE, and it is related to the Cáceres demonstrator. And the comments are listed here and can be listened to simply by browsing. This is a sample comment attached to an object that is identified by this GUID, this global identifier. And just by using this global identifier, we can link the comment to the corresponding IFC object, that is in this case, this wall of the case study. And we can check, in effect, if the comment is relevant or maybe it can be neglected, or in some cases it has to be designed a new renovation option that solves the issue. And from my side is all. I leave the speech to Alessandro. That will close.
Okay, thank you, Massimo. Thank you so much. I think you said what is relevant for ADOBs, for ODOBs, sorry. Nikos, in case we have just 1 minute, I might say some final word.
Of course.
Okay. And yeah, we'll try to share this one. Let's see. Oh no, sorry. All this problem with sharing the right window. Okay, let's try again. I suppose it's okay. Now you must be able to see the presentation
Yes.
that we've gone through earlier. Okay, so I think Massimo has made the presentation about how it works and the role of the web service that was developed along with the application. Final words might be about the testing that we have done in our pilot in Cáceres, Spain. Just to say that it was tested by 8 volunteers, 8 people that have no specific technical knowledge about this system as Massimo has. So just it was very useful to check how a technician and also not a technician can react and how fast people can learn about the use of this system. And we had very good feedback. The test took place in 2 different days. So we had one first model that was assessed in the first day, another model in the second day. We have recorded everything. So yeah, videos of their first person view and the comments that they left. And also we have some statistical figures about what the answers are in terms of their technical assessment, but also their feeling with the system. And this was done about every step that they did and collected in a couple of questionnaires that are under analysis just in this period. So this shows that the system is suitable for people that usually perform their work in this field, in the field of building renovation. Okay, that's all from our side, and of course we would be happy to answer any question that the audience may have. Thank you.
Thank you very much, Alessandro and Massimo. It was extremely enlightening, your presentation. We can proceed now to the last presentation of the ENCORE platform. Our last presenter today is Mr. Dulcidio Coelho, who is the technical manager of Smart Gateways, a company that is based in Manchester. Dulcidio is specialized in the field of electrical engineering and computer vision, and he is going to present us the building monitoring and diagnostics of the ENCORE platform. Dulcidio, I hope I got everything right. The floor is yours.
Okay, thank you for the kind presentation, Nikos. And as people usually say, leaving the best for last. So I actually need to lower down your expectations. This won't be the case. Can I just confirm that you're seeing my presentation correctly?
Yeah, Dulcidio, we can see it.
Okay, thank you so much. So I'm going to give you just a brief presentation, I hope, at least. So let's just start by doing giving you a very short forward in terms of the 2 SMEs that are developing this module for the ENCORE project. So as Nico said, so I work for Smart Gateways. Actually, I'm one of the directors. And we are working in partnership with a Portuguese company called SPA. And both very small companies, but with an interesting track record in terms of European projects as well. So basically, we focus a lot in terms of developing solutions for the Internet of Things, and we focus particularly in the aspect of interoperability. So basically, and because of course this is mostly based on industry settings, is when you have your computer is getting too old, doesn't have the features, you buy a new one. In the industry, you have a machine that costs hundreds of thousands of euros. it's not modern, but then it's too expensive to replace with something that has other capacities. So what we work a lot is giving back some of the new expectations in terms of the technology to all the equipment to bring them to life. So that's why we focused a lot in developing this capacity to integrate different systems into a same platform. And that goes also for not only for the hardware side of things, but for the data side as well, because as we don't develop full platforms, so what we're doing is integrating things within existing settings. So some third-party applications will require a certain formatting for the data. So we look a lot, so we have to look into how to exchange these data in the correct format. So we focus a lot on in terms of flexibility, so on the capacity of the same platform to adjust to changes in their industrial setting, and also around scalability. So how can you actually add more and more sensors or more and more actuators to your platform? So that said, let's look at let's start with the real presentation around what we're doing within ENCORE. So you've seen a set of brilliant presentations of how you start, how you take a renovation project from beginning to end. The bit that was missing, obviously, was how do we actually, on one side, how do we use these to validate all of your simulation models as well, but also to understand that buildings and equipment grow old, and that some of your initial assumptions may change over time. And also building occupation changes a lot of your calculations, because all of your simulation is done based on assumptions of how the building or how the spaces are going to be used. So the idea of this module is that we have a physical sensor network that monitors all of your comfort and energy consumption variables, so that we can evaluate over time if there is a degradation of performance, or to feed back into your control network that is also provided by some of the other modules in this project. So breaking down in terms of objectives, we're looking at designing a system that allows sensors from different, using different protocols to be integrated within the same platform. Obviously, to develop an integration with the ENCORE platform. So although this runs as a completely self-contained external service, it offers the necessary tools to be integrated within the overall ENCORE solution. So through the ENCORE portal, you can actually get access to all of the sensor information and bring it in within your renovation project. So obviously, you've seen the pilot lab in Spain, in Cáceres, and you've seen that, well, you might have seen in some of the image, exactly on the previous presentation, there was some images of the inside of the building. And of course, there is a full sensor sensor network already installed on those facilities. But what we present here is also a low-cost integrated solution that that can be taken into any renovation project and be installed, so that you can take all the full functionality that that ENCORE project offers. So one of the other objectives is also to create to have a dashboard to monitor the sensor data, and a user app that allows a final user or somebody that is monitoring the project to understand or quickly understand what is the current live situation and what has been happening for the period since the sensor network has been installed. So in terms of the smart gateways platform architecture, what we have is we have the physical aspect of sensing and actuators. So from your usual environmental sensors to CCTV cameras to traffic lights. So there is a multitude of technologies that are deployed on the ground that use a very specific communication protocol. So the first level within the platform is a middleware to be able to connect to those physical protocols. So we create a series of connectors that allow these devices to be turned into a virtual object within the platform. So this makes the system agnostic of any technology. So it creates its own representation and its own stack of properties for each object, list of properties about what values does it record, what type of reports does it generate, what commands does it accept. And so once you have that in place, so this allows us to have another feature within the platform that can, for example, in this particular example, you're seeing there is a temperature sensor that is that has been read. The internal control protocol read that sensor, decided that, for example, it is too cold, is going to turn on the boiler to warm up that space and sends the command to that boiler. So all of that internally, as I say, is agnostic. So there is a common language that doesn't care if a device works in protocol with protocol A, B, or C. So basically it translates it appropriately to that. So you can define your control cycle ignoring the exact commands that need to be sent from device to device. This also, by having an API and have a link to a cloud system, it allows other third-party applications to take this role. So it doesn't need to be the box that you have inside your house that does all of that control. It could be something on the cloud that is doing that control. In this case, for example, it could be sent to the ENCORE portal, the building management system or module can take that on board and say, well, we need to change the settings of that boiler. So this can be an internal loop or an external loop generated by a third-party application. Just how we use a gateway to make things smart. So this is I'm going quickly through these. It's just a presentation in terms of the underlying architecture of the platform that has been developed, and that is alive inside the gateway device. So the first step is of course there is a core aspect to the software application that manages all the services and the modules operate. So of course it needs to keep check that all the internal functionalities are up and running. There is also provides a real-time system that allows us to remotely diagnose and monitor the internal behavior of the gateway. And there is also an aspect in terms of cluster management when we need to have more than one gateway within an installation. So these things cover the connection hardware of the gateway itself, a back office system to allow configuration and adding new sensors and adding new metadata to sensors and use other personalized configurations. So in terms of virtual objects, you have sensors, actuators, functions, and remote services. So for example, the idea is that you can have a real sensor, but for example, let's say you cannot, you need to measure how much energy we are using for heating, but you are actually using burning logs. So it would be very difficult to automate that process and have a sensor that checks how many kilos of logs you use. So we can create a virtual object that represents your boiler, and you can, for example, manually input those values onto that system. So although there is no sensor attached to it, there is a virtualized sensor within the system. So of course, so there is several modules that are connectors for each of the protocols we support. It runs a set of message brokers to allow communication with different platforms, including things like FeeWare, which is again something that was funded by the European Union in a Framework 7 project, and it is basically the definition for the future of the internet, how it is planned to work in Europe. It has a set of translation APIs allowing us to export the same object data, but in different formats, depending on the systems that are going to consume them. A user management framework, and it also allows us it also supports different languages to create different new functionality on the system. So it has a very simple macro engine that allows you to create very quick automation control cycles, like if temperature below 15 degrees, turn on heater, for example. It is very simple mechanism. A more complex way of scripting those. So when you have more interactions and more operations to take in consideration, and also a template engine. So for example, you are using the system to monitor a network of sensors, and you need to export that, for example, as a HTML page to a third-party application. So this template allows you to fill in, to create the template of what the data structure will look like, and then it will replace the actual sensor data within that module. So of course, it connects to the cloud services, which then in turn offer a set of API real-time systems and other web services to the user. So currently, or for this project, we are using this device that again is a gateway that is basically a system, a SOC system on chip. So it's a very simple integrated processing unit with a set of interfaces, also been developed as part of a previous European funded project. Now it's a large company in Denmark called Velco. So the one we're using provides directly support for Zigbee, for wireless M-Bus, for Z-Wave, Wi-Fi, Ethernet, 3G, and it has a USB connector that then in turn allows us to expand the number of modems to other protocols like Modbus, Connect, 4Nox, X10, and even the simple RS485. So there is basically, as long as there is a modem device that supports a protocol, it can be attached to the gateway. So in terms of the sensor the sensor array that is needed to cover the needs for this project in particular. So on the energy consumption side, so there is a series of aspects that have to be covered. So on one side is electricity consumption, gas consumption, or other fuels. So whenever there is a smart meter installed, so this already allows us to get a reading from electricity and gas consumption. Excuse me. So overall, obviously, it is overall consumption of electricity for a building. So you need then to put in place an algorithm to break it down in terms of what is energy for what is your baseline for lighting, what is your baseline for other appliances, and then the rest of it would be what you're using for heating. We support currently Modbus and PLC. PLC is power line communications. So it's an algorithm that is a protocol that's actually used in Portugal. M-Bus is used in several parts of Europe. Unfortunately, here in the UK, it's Zigbee, but it's not an open system. So there is other ways of getting to that information. So when you have a simple electricity meter, all of the modern ones will have a pulse generator. So there is a light that flashes a predefined amount of times per kilowatt. So by being able to monitor how many times it flashes, you are able to read the consumption. Also for which is more practical for individual metering of devices, you can use a smart plug. So this one illustrated is a Zigbee one. So it directly links to our platform and allows you to measure to do a continuous power measurement of the unit that's consuming that energy. And we are going, as you can see, from the less intrusive to the more intrusive in terms of requiring a technician to actually do the job. So the current mirror measuring devices, so basically the clamp you install around the power cable, it actually measures the current that is passing through that cable. So by deducing, or also by knowing what is the voltage supplied, you can calculate power consumption. So this is, in a sense, is slightly better because it allows you to individualize which line you are actually monitoring. Some, like the one represented there, also needs to be powered, needs to be connected to the power line. Some others, like the one you see for the pulse detector, use batteries. And finally, when you really require a proper metering within your installation, with dividing what is spent on lighting, what is spent on energy, you can install a device on your switchboard using a power meter using the DIN format. For the project, we're using, as I said, we're using Zigbee because it allows it's a fairly cheap protocol. It is very low power, so we worked in partnership with developers to develop some of these sensors and to improve their energy consumption. So, for example, some of them run on AA batteries, and like this one, the temperature and humidity sensor, and the batteries last for around 2 years. So so it makes the system cheap, easy to maintain, and accessible to non-specialists to install in the properties that are to be monitored. So also ability to look into air quality by looking at CO2 concentration and also volatile organic compounds. So basically any kind of gas that can affect your health. So to install the monitoring platform, so the user gets a gateway, a proper energy monitor for oh, sorry, just before so for gas installations, most of the, if you don't have a smart meter or a meter that can be read by any other method, attaching anything to your gas installation is most of the times require the installation of a flow meter. So that requires a specialized technician in gas. So it's always an intrusive part of the process. So there is always, in most cases, the option to manually input gas readings on the platform. Regarding installing the platform itself, in this particular case of the platform we developed, so there is an initial automated setup. So all the sensors can be paired with the gateway or discovered by the gateway itself when adding these to an existing sensor network. There is some protocols that actually require the devices to be added manually on the system. Again, not the case of the kit that we will supply for building monitoring. And there is always a technical intervention needed because one thing is to automatically pair devices and the gateway. The other thing is to actually tell the gateway on your definition of the information stack for a sensor, what some elements around the metadata, like including the location, a description saying, well, temperature sensor in the living room or humidity sensor in the kitchen. So, and also to comply with the needs of the Encore platform, you can also attach an IFC ID. So basically, you can actually link a specific sensor to your initial IFC file that you loaded in the project. So when you are visualizing on your BIM viewer the building you are monitoring, you have the anchors for the sensor, so you can directly from there explore what is the current reading, what is the reading for the last 5 days, the last months, or previous year. So in terms of the support for the platform, so there is a back office element to it. So where during installation or configuration of settings, it is used. It allows also real-time monitoring of all the installations. So as you can see on the screenshot of a group of gateways, you can see that the ones showing in green are active. There is a column there that says last communication. So the system keeps in touch with the gateways. The gateways upload data to the system. The system and they have a heartbeat that tells the system that they are working, and they upload all the status information for sensors. So for example, the ones on top are in blue, means that they have disconnected, so there is no information for a large period of time. And so that's a quick dashboard to understand what's happening. And also the back office also allows us to change the current software in the gateway. So whenever we need to do an update, fix a bug, extend the functionality, this all can be done by the gateway. So we don't need to remotely to go to location and link directly with the gateway device. We can do it remotely. So just a view of what the sensor looks like on the back office. So each sensor is defined by a stack of properties, and we followed our internal development very closely to the Zigbee standard, because it is very exhaustive in terms of the definition of properties. And on top of that, we had to add also several layers for metadata, like the IFC ID and all of those fields that are not part of any of any protocol in existence. So when you are on the back office and you get to a specific sensor, so by the way, this is a smart plug, and it is linked to an outside building. You'll see those areas in pink because represent a value that has been recently updated. So there are, for example, configuration elements. The gateway doesn't, or the sensor doesn't keep pushing that to the gateway. So it only sends the fields that have been changed since the last time. So by looking at that, you know when it was the last transmission, what was the last value read, but other properties are static. So for example, if you create a sensor, the sensor ID, for example, it won't change. So it is set at the beginning when you do the installation, but then it stays there. The back office also automatically detects what type of commands does that device accept. So in this case, it's a smart plug, as I said. So it actually accepts two specific commands besides the command identifier. The command identifier usually is used when you lost control of what that device is, and you have a name, but you really don't know where it is located. So we can say a command identifier, and the device usually blinks, or will do some other way it will identify itself where it is. You can send commands to switch it on or off directly from the back office, or they are also offered with the API. So third-party services can, once authenticated, can send these commands back to the sensor. So there is several other entries to configure the sensor, like details, where you add the metadata, the extra metadata that needs to illustrate what that sensor is. You can configure reports, because some of these sensors, especially the ones that are based on very low power architectures, they tend to report information within very long periods, so they are not continuously on. So you cannot read them. So they will wake up and upload data. During that period, you can actually update how frequent they should send data. So of course, if you say that you want to get temperature sensor every minute, the batteries are not going to last for 2 years. So the system by default takes samples every 2 minutes, but this can be shrunk or expanded. Also within this platform, you can immediately actually have asked to generate a chart for readings. And for example, this is not for the previous one, which was a smart plug. This is for a temperature and humidity sensor. And you can immediately see the graph showing the last 5 days, and you can expand to any period you want. Just a quick justification of why it has minimum, medium, and max, because although the gateway is sampling the sensors every 2 minutes, it basically it only uploads to the cloud chunks of 15 minutes. So basically it sends what was the average reading for those 15 minutes, and also during that period what was the minimum and the max. So as you can see, sometimes the line they are perfectly matched, so meaning that the medium was actually the same as the maximum and the medium, but some periods you will see there is a small difference between one and the other, not very much, but a bit. So talking about how these all integrate with the requirements for ENCORE, and as you have on the left hand side, you can see, well, you have your house with a smart gateway, with a gateway, with the home gateway, a smart gateway that is linked to the internal sensor network. This is also linked to the cloud services. The cloud services obviously store all of this information and allow you to do an analysis on sensor data over time. So all of this is made available through a RESTful API to the ENCORE through the ENCORE portal to all of the other services that are part of the solution. And just a brief word around the API. So as you can see, it has a series of endpoints. The first one is called server. So basically is where you do your authentication. So that's where it deals with the authentication user that is making the request. So you need to log in on the system. You get a token that then you can use on the subsequent requests. The second endpoint is called gateways. So so you can have access to one gateway, or if you are like a building manager and you have a series of buildings that are under your supervision, you can have a range of gateways that become available to you. So you can use that endpoint to query which gateways you have access to, what is, for example, their location, so that you can then identify, have an ID for that gateway that then you can use to query the sensors. So when you get to the endpoint sensor list, you can query, you can get a list of all of your sensors. You can query by a specific ID, IFC ID, if it is linked within your ENCORE project, or an IFC tag, or just a description. So it allows you to do that search. And once you found the sensor you want, you can use another endpoint to get the current data. So either a current value, a time series of values. So you can request the system. You can do all of those requests on the system. It also has a put property that allows the platform to fill in some of the metadata for the sensor. So instead of using the back office to tell this specific sensor that is in this wall is linked to this specific IFC file, so you can do it the other way around. So you can use the ENCORE portal to fill in all of that information. This is the API documentation that actually gives examples on how to do the API calls using different languages. So you can see it offers a variety of languages to request that information. It also another endpoint of relevance is the gateway alert. So it allows any third-party application that is using the API to get alerts from the gateway. So be it faulty sensors, communication problems. So any of that can be subscribed by a third-party user application. and you can also push notifications to the gateway. So, for example, if you put you can install a siren with the gateway, and you can send alert to the gateway to activate. So, for example, again, very applicable to alarm systems that can be integrated within this platform. Taking a step aside and actually presenting something that we were not capable to do with the IDEA building in Cáceres, was that they have a sensor network, but it is a proprietary system. So basically, the company that did the installation used a system that doesn't allow us to link in and access the sensors directly. So it has several layers of encryption that, without us knowing the exact settings, we cannot read the sensors. But because, again, there is a dashboard which is an HTML, which is a set of HTML pages that actually update the sensor readings every 30 seconds. So we use what's called scraping. So basically, it's going inside an HTML page and looking for the components that we want to extract. And on this particular case, we can identify what is the sensor ID, what is the description of the sensor. So as you can see, there is an indication of what it is and where it is located, and also a value. So this allows us to retrieve this information from these HTML files and still create the sensor, the virtual sensor representation, as if we were actually linked to the actual sensors, although we are just stealing the information from another page. But still, for the platform, it's transparent how this operates. It is the same behavior if it was a real sensor, or if it is just taking it out of a third-party application. As described also on the aim of the project and on the objectives. So the platform needs to offer a sensor dashboard. So something that you can use to look at your energy variations, to do potentially overtime comparisons. So when you assessing the degradation of your energy performance, you need to look at what's been happening across time. Obviously, need to calibrate that information based on external conditions, because you cannot compare months of March this year with months of March last year if the weather has been completely different in those periods. So we need to calibrate that information to understand if there is a degradation of these elements. So the dashboard itself, the first column, the first line, you can see there is a range of sensor types, and it's showing actually current readings for those sensors. As you move down on the dashboard, you see the graph for the period you select. So in this case, you're looking at temperature and humidity charts. You're also looking into occupancy. So as we provide some motion detection sensors, so this allows to understand the time of use of the different spaces. For example, you can see on the first motion map, there's activity starting at 6 a.m. So basically, if this is like a working space, it will allow you to understand that there's nobody using that building, that location before. So you can your comfort parameters can be adjusted for no people in there. So you can reduce the temperature or the cooling, the lighting, and so on. So this allows you to understand the occupation pattern for spaces and adjust your control algorithm to take that in consideration. Something goes for illuminance, as you can see on the bottom. Of course, because again, it's doing that in 15 minutes periods. So that's why you see huge variations between what is the average and what is the minimum and maximum readings. because as these may include sunlight interfering, it might, if the sun shines brighter during those 15 minutes, you'll get a really big spike. But that is also a good indication of how a space has been used, and it also allows you to understand the interference of natural light within your environment. To conclude the
Lucidio, sorry, if I may interrupt you.
Oh, I'm not finished. Just 2 seconds.
Okay, I would kindly ask you to speed up a little bit.
No, it's really the last slide. Sorry.
Okay, great, thank you.
So it's just a quick overview of the user app. So again, for most people, looking at graphs that show what is the temperature variation, what is the humidity in the space, is something that is not clear in terms of is this ideal? Is this not ideal? So what the dashboard of the app allows you to see is, although it shows the sensor reading, it gives you a semaphore type indication of the comfort within that space. If it is green, it means that it is within the design parameters. If it is amber, it means that it's a bit outside of that. If it is red, it means that the space is not comfortable at all. And same thing goes for energy, where you can actually do a live monitoring how much you are consuming currently, and look at the other periods of consumption. Sorry for extending too much my presentation. Thank you for your time.
Thank you very much, Dulcidio. That was the last presentation for the ENCORE project. As you can see, as everybody can see, it's a really multifaceted project bringing together all kinds of different scientific fields. Next up, I would like to introduce Dr. Yorgos Artopoulos and Dr. Stavroula Thravalu from the Cyprus Institute, who is going to present the Urban Periscope project and also the BEEP project as well, also related around BIM as well. The floor is yours. Thank you very much for attending.
Thank you, Nikos. Thank you very much. And thanks for the introduction. While I'm trying to share my screen with you, can you please confirm that you see my screen?
Yes.
Great.
It's trying. So 1 moment. It's trying to load. No, we only see a blank.
Yes,
page.
That's the one.
Okay. Now it's okay.
Excellent, great. I would like to thank the ENCORE Consortium and the coordinator for accepting to this joint presentation, as well as the Technical Chamber of Cyprus, and of course you, Nikos, and Talos for all the support. So please allow me to say a few words about our lab, the Virtual Environments Lab at the Cyprus Institute, where we work on immersive environments, urban modeling, and digital simulation for the study of built heritage and the creative exploration of historical narratives, and where we are developing ICT-enabled user-driven tools for social resilience and inclusion with an application in historical context. Of course, naturally, the work that I will be presenting and following by the presentation of Stavroula and Christis Alexandrou has been collaborative work, and has been the result of the many collaborators and colleagues at the lab, some of which you see on your screen. So as I mentioned, most of the activities, the research activities that we are conducting at the lab actually cover, in terms of their technical workflows, steps and parts of this pipeline that you see on your screen in terms of the data provenance, and which is a pipeline that we developed in order to enable us to reuse and apply different tools and techniques and data processing in different scales. And it covers the scale of architectural features and objects in buildings, the study of whole buildings, and as well as their operation and energy performance, and up to the scale of a whole neighborhood. And specifically, we're looking at ways of monitoring historic clusters. In this context, we decided to present a couple of our ongoing projects, our current research activities, which cover different scales, as I mentioned. And as you will see, they are in many ways and at different levels very complementary to the fantastic work that the ENCORE Consortium is developing. Obviously, there are some anchors, some overlaps, and these regard specifically the use of building information modeling platforms for accessing these wealth of data. So in this framework, I would like to start with a presentation of one of our projects that focuses on the monitoring of historic clusters. And this is something is an area where our activities differ to the operation and the focus, the scope of the ENCORE Consortium. And before getting into more details about the project, I think that it was just offering a glimpse to the motivation behind the creation of these activities, which actually stems from the everyday reality and the challenges that we are facing in the so-called second and third tier historic cities across Europe. And this is important because these are cities which, unlike cities such as Bristol or Vienna and Barcelona or London, which are very rich in terms of their operations, they are lagging behind in terms of smart city tools and with all the capacities that these bring. And you will allow me to explain what I mean. So even though, for example, to bring you the Cypriot context, even though in Cyprus, most of the authorities, if not all the authorities and the stakeholders, do recognize of the very positive impact that local heritage assets have on the successful urban regeneration of our cities in terms of their socioeconomic benefits, we are still facing the loss of our built heritage every day, which is the result of various causes, including the pressures from real estate development, of course, neglect by the owners, and the impact of climate anomalies that is a reality, especially so for the solar belt and our region in the Middle East, which is, as you know, a climate hotspot. And another important pressure is in such cities is the result of the very rapid urban development, which in some cases was also unplanned, as you see in the case of Nicosia, where all the satellite historic villages around the city have been integrated in the urban fabric due to urban sprawl. So, as I said, of course, everybody acknowledges and recognizes the positive impact that investing in built heritage could have in our cities and in reuse. And also, it is well understood that in the context of the Green Deal and the targets that the European Commission has enforced, there will be a huge need for renovating our building stock. Still, we do have a long way to be able to offer to all the stakeholders the necessary tools that they could really implement in practice, and they could help towards covering this problem. So our project, of course, was motivated by the agency of safeguarding our building stock, the proven socioeconomic benefits of reusing and conserving built heritage and heritage buildings, and the expected need for renovation. And it identified specifically the gap and therefore the challenges, which in terms of the level of the authorities can be focused on the lack of data by the authorities, which of course doesn't help them to really address the issue on an individual scale of the building, but also the tools in terms of monitoring at a different scale, as you will see later on. In terms of the professionals, they lack access to data, and the guidelines and the processes that would enable them to collect and generate these data. And in terms of the owners of the building stock, the lack of guidance for renovation, and of course in some cases, unfortunately, they lack any appreciation of the heritage. In order to respond to these challenges, we brought together expert members from research organizations and universities, with SMEs, with companies, experts, and active in the relevant technical fields, with local and international stakeholders, as well as professional and international bodies, in a quadruple helix to deal with this issue and produce an online BIM-enabled platform that would help both the officers of the local authorities, as well as the practitioners and the owners of the buildings, to embrace this transformation and this change, and give them the capacities to have access to such data. So in this effort, of course, similarly to ENCORE, we tried to bring together the data that were generated by documentation on the site, with LCA, life cycle assessment information, as well as non-destructive testing techniques that would enable the building owners to better, and the professionals to better understand the specific issues, structural issues, and in terms of the material construction that their specific building might have, and to provide access to all these data sets through the use of building information modeling platform, and specifically the central role, of course, plays the IFC file that links all these data together, as well as in providing access for remote collaboration through a digital twin of the building. I'm not going to describe each one of these data sets that represent, or that they were generated by each one of these steps that you see on your screen, because we are all familiar with the importance of this information. I just want to mention the integrated process that we are following, that combines, as I mentioned, non-destructive testing information from the buildings, with terrestrial 3D documentation, as well as aerial documentation, but also the results of remote sensing study of the specific areas to which the buildings belong. And I will be talking more about that in a while. So as I mentioned earlier, our focus, unlike the ENCORE project, lies mostly on creating this platform with these features and tools and the data sets for the specific buildings, as a means, as a vehicle to demonstrate to the local authorities and the practitioners of the importance and the value of approaching the challenges of our built environment through the use of said tools. And therefore, what was the need for us was the development of the relevant workflows and guidelines and instructions for each one of these target audiences in order to enable them to embrace these technologies. So in this context and in this effort, of course, our focus was on how the several activities would link together in terms of the interoperability of the data and the data provenance. And for doing that, of course, and addressing these target audiences, we have been investing a lot of effort in producing all these documentation and instructions and guidelines that would help the future targeted users of this platform. And of course, as many of you may know, any effort of integrating all these data requires a lot of focus and support in terms of the management and the structuring of the metadata. And for that, we have been working on developing a specific a schema, part of which you see on this process graph on your screen, which would enable us to link together metadata about neighborhoods and therefore the neighborhood scale with metadata about the digital assets that describe and the attributes that describe specific buildings, always from the point of view of the various actors that we are addressing our platform to. And this, what you see here, is a schematic of the platform that we are building. And I just want to mention that in the back end, we are using a specific open content management system framework, which is called Clouder for the handling of the data and the metadata. And through this platform that I'm describing to you, the users would have access to geolocated information about specific buildings, as well as their neighborhood. So in terms of the building, obviously, since we are talking about a BIM-enabled platform, the user has access to all the attributes of the IFC file, as well as access to the results of the 3D documentation of the file as a mesh and as a point cloud. Regarding the point cloud and the whole process of creating the building information model of our pilot buildings, naturally, we have been similarly exploring different possibilities for semi-automating the process, or at least to better understand what this would take. But specifically, since we are focusing on historic buildings, we were fully aware of the difficulties that actually segmenting and annotating the very complex and irregular geometry of heritage buildings could pose a serious challenge in trying to automate this process. And we have been exploring this in the context of another parallel activity that you see on your screen, where we used convolutional neural network in segmenting a 3D model, specifically oak trees, which is like a 3D. The oak trees are produced from 3D point clouds, voxels. Yeah, I remember. And you can see here the results of the automated segmentation and annotation process of these trained algorithms, as well as we tried to do the same. Sorry for the wrong order of the slides in terms of 2D for the segmentation and annotation of the facades of our buildings. And as I mentioned, this was mostly done as an exploration for us to better understand how this feature could possibly be integrated in the process. However, exactly because of the practical difficulties of the complexity of the geometry, we followed a manual process of building the BIM model by snapping on top of the 3D point clouds, and mostly focusing on the textures, on the materiality of the building, exactly because of the importance and the central role that the conservation state analysis process would play in our field. Naturally, we have been developing families for each one of the objects in the BIM model that could be reused. And as I mentioned, again, the effort was for us to produce the data sets that could become useful in the future for both the professionals who are working and are active in building a conservation and renovation, but also for the offices of the relevant authorities. And this is why we have stakeholders such as the municipalities and the Town Planning and Housing Authority as partners in our consortium. And you see here some of the material databases that we are creating. And of course, this tool would allow for phasing, for the phases of for representing the phases of the building, as well as a better analysis of the typology of the buildings. And besides, like as I mentioned, the conservation state analysis with the use of typical documentation processes and representation tools, we also focus on the providing online access to this information for the collaborating stakeholders and partners. And this is an example of how an online VR model could be viewed by the relevant users, specifically for the study of the condition of its structure through the exemplar case of the thermographs that have been placed in the exact location where they were taken during the NDT. And all this, as I mentioned, can be accessed online, these digital twins, through the QR codes that you see. And multiplying this process to better understand the value and the activities or the interest that might have been taking place in specific historic clusters in our cities is becoming a reality, and it's elaborated through the study of several such cases, such buildings that were carefully selected based on specific criteria that you see here, including, of course, architectural, historical value, location, typology, condition, etc. And in applying this, we decided to focus on two different areas in Cyprus, specifically in the Turkish Cypriot quarters of Limassol and in the Strovolos area in Nicosia near the Pediaeus, the inner park of Pediaeus, because these areas not only are populated by different types of heritage buildings with different typology, as well as different construction methods and materials, but also because they represent different social conditions, and specifically in the case of the Turkish Cypriot quarter in Limassol. And moving to the next scale, these are the two case study areas to our next scale, which is that of the neighborhood. Of course, we used aerial photogrammetry, aerial documentation techniques in order to cover the surrounding structures and buildings of the specific pilot cases that we are focusing on. And further on, we integrate the results of data analysis of remote sensing in both neighborhoods, in both areas, specifically in terms of the land surface temperature, in order to enable the relevant users to have access to this information through a GIS-based platform, and therefore to move from a purely visualization tool like the one that you just see here, which was created in Unity, into a GIS and BIM integrated tool that not only offers dynamic access to dynamically updated data sets about the built environment, but also access to the documented point clouds, as well as in the scale of the building block, and to BIM models in the scale of the particular building, but also doing so by providing access to neighborhood scale data, environmental data that would help possibly better understand to all the relevant engaged professionals to better understand the impact that a long-term exposure of specific materials and constructions would have to the climate of the specific environment. And with this, I will stop. These are the results of the project, and this is how we respond to the targeted needs of each one of our user groups, and by providing a planning, by enabling planning and better monitoring through linked data to the public authorities and policymakers, by providing all the good practices, instructions, and guidelines to professionals so that they can develop further on similar data sets that would be automatically uploaded on the platform, and also by providing renovation guidelines and examples to the owners to facilitate and help them grow and a better understanding of the cultural and social value, as well as the economic value of renovating and conserving their properties. And I will stop here and pass the floor to my colleagues, Stavroula and Christis, who will be presenting to you the work that we have been developing and conducting in the context of another European project.
Yes, hello from my part. Can you hear me?
Yes, yes,
we
can hear you.
And you can also see my screen, I guess.
Yes.
Right, just give me a second. Okay. So this second part of this presentation will focus on building information modeling for energy efficiency in the public sector. In the following minutes, we'll present you shortly the BEEP project and its methodology, but we will focus mainly on issues regarding the interoperability between BIM and building performance simulation that we have encountered along the way. Finally, we will present and share with you some tools that we have developed regarding the dissemination of the results of the project and the engagement of stakeholders, and particularly in this case, the visualization of energy consumption through virtual reality tools. So BEEP is an NECBC MED project that has started in 2019 and is expected to finish by the end of this year. The Cyprus Institute has collaborated with many partners in the Mediterranean region, in Lebanon, Jordan, Palestine, Egypt, Spain, and Italy, and particularly CNR is coordinating this project. The thematic objective and priority of this program is to support cost-effective and innovative energy renovations with a focus on public buildings. More specifically, BEEP project aims at strengthening the use of BIM tools to enhance energy efficiency in buildings. the expected outcomes of the program will provide public administrations with a powerful method to be used in the energy rehabilitation of public buildings and support the whole process of finding private funds through the energy performance contracting scheme. This innovative methodology is tested on heritage public buildings, and this is what makes this project very interesting and also very challenging, and not only in terms of interoperability, but also in terms of methodology. So the first step of this methodology involves the elaboration and incorporation of various data sets. The first one, as you can see here, concerns building assets, heritage significance, and conservation state. Also environmental aspects such as climate data and energy audit of the building. Second stage involves dynamic energy simulation and the sixth dimension of BIM. Passing on to the creation of an enriched energy efficiency BIM model with the extraction and the calculation of other parameters such as the return of investment and the elaborating and enabling the process of attracting ESCOs and obtaining an EPC contracting. So the case study in Nicosia is, the pilot case study in Nicosia is a building that has been abandoned many years now. It has influences from the British colonial architecture. It is going to be renovated as a municipal museum. And in the process of documenting this building, we have proceeded with terrestrial photogrammetry and the creation of a 3D point cloud. As you can see here, some of the results through the process and the fitting process that we succeeded. And the environmental analysis also involved the characterization of the thermal properties of the materials, as well as indoor and outdoor environmental monitoring. All these data were incorporated into the model. So once we had the BIM model created in the platform, we also incorporated a number of data that are related to occupancy schedules, HVAC lighting schedules, but also the thermal properties of the materials and the building components that are also represented here. So having created the energy efficiency BIM model and passing on to the next stage, that is the dynamic energy simulation of the building, we have encountered a series of challenges. And at this point, I would like to give the floor to my colleague, Christis Alexandrou, to enlighten you further.
Hi, everyone. As also previous speakers mentioned that challenging chapter with interoperability. First of all, for our audience to know that this is a topic that concerns the research community, and of course, for BIM, a method that it's supposed to boost collaboration between all the involved parties in construction buildings. The objective here is to turn it from a semi-automatic approach to a fully automatic approach. And this will, of course, cancel or avoid any unnecessary remodeling between the architect and the energy engineer. And at the same time, will ensure that there is no errors on data registration during the process. Above all, solving this issue will, of course, enable the full utilization of BIM parametric capabilities, and of course, then will open the road for design optimizations, either this concern the building or its energy performance. Begin with, we're using mainstream application like Autodesk Revit and Design Builder. The exchange is happening through the GBXML schema, and this approach is divided into two parts: the geometric translation between the architectural model and the energy model, and of course the alphanumerical data or the metadata of the thermal properties of all the components included in the BIM model. I'm going to talk later about the method we developed for solving some of the issues. So first of all, the first thing we stepped on heritage assets is the fact that openings differ from semi-glazed to fully glazed or partly glazed, which is something that you cannot very often observe in contemporary construction. And mainstream BIM native softwares have a separate function for windows and doors. And here we needed to find a way to either nest a family that includes window and door components, or otherwise manually calculate the U values for an entire family, and using the schematic types options that is provided by Revit to register that information into the construction XML file inside the Revit directory. It's an XML file that I think easily someone can edit it and just add some more lines and with the properties of these components. And here we are talking about doors and windows that are composite, that have something unique and complexity. And the entries include the name of the component, the U value, and of course, according to the type of the building element, the appropriate thermal properties. This also applies for composite construction like curtain walls, which here again in the XML file, someone can use the layer ID property and then add all the material IDs that built up that wall. And of course, in order to make sure that the process will be successful, before exporting, someone needs to cancel the default override of the schematic types under the advanced energy settings in Revit. Here, just for the audience, we are mentioning some of the basic exporting methods. In this case, we are using rooms or spaces, and in the additional options, we are using the export complexity will be simple with shading surfaces. And respectively, in the energy simulation software, in Design Builder, we are using the minimize gap between blocks option. In terms of geometry, also for contemporary structures, also here for heritage buildings, the fact that the two models require a different approach. On the one side, we have the three-dimensional building of the architectural model, and on the other side, we only have the surfaces. While calculating, while the geometry tries to translate, the default method that BIM software are using is converting existing walls using the wall center line, and that creates some anomaly in the geometry, maybe some edges, some corners that principally this is one of the major issues that people are countering. And what are we suggesting so far for architects that they want to try to improve their BIM models is designing using the energy in their mind. So each wall can be edited, or an instance can be created with a different center line that can mostly fit to the purpose of the export for the energy analysis, instead of focusing more on the architectural detail part. Also here with the different openings in heritage buildings, the fact that you have an opaque and transparent envelope in a single opening, someone can either follow the approach of nesting two different families together, or simply using a door family and then manually modifying that opening in the design builder, in the energy simulation software. Now, our first experience with this went quite well, but we were missing some of the data, and mostly we were missing the occupancy schedules, lighting schedules, HVAC systems, which is also a very important part of the process, especially if someone wants to try different scenarios. The solution that we are thinking on this aspect is using the latest, at least, version of Design Builder has this interactive table of all the data collected. It can be exported into CSV, which then can be used, can be read using the Dynamo visual programming tool that Revit provides, and can be easily replaced, first read and then easily replaced using the already registered data in the BIM model, then exported and then sent back to Design Builder. Again, there is no need for manual registration of that information. Lastly, the last part, as Stavroula already mentioned, after the analysis and the simulation results, we're working also on visual reality tools that can allow the stakeholder to visualize, or the project clients to visualize the results and the consumption of the building in different during different periods of the year more easily. For example, here we're drawing sectional cut of the building, and then the slider below changes the month of the year. So getting a more closer look, you can see also the colors changing and the consumption values are demonstrated on the model itself.
Sorry, Christy, if I may, to add here that the value for this augmented reality tool is for us the way that it has been built from the bottom up. It's not like just an application of an existing tool, specifically because it draws data sets from our Clouder database. So actually we are aiming through the development of this AR tool, we are aiming in setting up the process where the different collaborators could update the models in the database and automatically could see the different geometry as well as the different results varying and can interact with them.
Exactly, and that's the end of our presentation. Thank you for your attention.
Thank you very much, George, Stavroula, and Christy. Extremely interesting presentations for both of the projects. And I believe that we have actually reached the end of our workshop, for events. Please let us know if you have any kind of questions regarding any of the 3 projects that have been presented, and we will do our best in order to answer them. As far as I can see, there are no questions actually that are present in the Q&A section. So that's either a good thing or a bad thing. Either we were completely clear on what we presented, or nobody understood the thing. Hopefully the first one. I would like, in any case, I would like to thank you everybody for your presentations and your presence. With regards to the ENCORE project, we are going to circulate a small 10 questions questionnaire in order to evaluate some things about the way that presentation was structured. Is there anything that anybody would like to add with regards to this presentation?
I would like to add something.
For sure, Sebastian.
Thank you very much for giving us the opportunity to present our project here. So thanks for this and for organizing this.
Our pleasure.
I would like to repeat, of course, the gratitude and the return, Nico, and of course to Sebastian and the whole ENCORE Consortium for having us here today.
It was our pleasure. Hopefully, we showed some really innovative ways that BIM can be used in rather not unconventional, but not so much well thought out processes of the way that we are doing business currently. Again, thank you again for everything.
Thank you very much.
If you, there are some questions in the chat. If we need some more information, where we can find them, Ioanna. With regard, if you can send an email to me regarding anywhere regarding any of the three projects, let me. Here is my mail in the chat for everybody, and I can coordinate accordingly and direct them to the right person. All of these developed solutions, all of these solutions are still under development. That's why we could not yet deep dive into the market aspect of those. So it is still under development. That's why we thought it would be good to present it to the actual users, the actual stakeholders. That is you, the engineers who would use them, in order for you to evaluate them and comment on them. So again, thank you very much. Thank you very much for your time. And we hope all the best for the rest of the day.
Thank you, everybody.
Thank you.
Bye, everybody.
Bye.